Okay, so instead of this being a tutorial video, this is an extra help video in the sense that we did this in class, but I wanted you to make sure that you understood where we were going. So if you had a hard time understanding this in class, this tutorial is for you. We had this question and I asked you to put this in vertex form. So when I put this in vertex form, I subtract the 100, I factor out the 3, and then I decide what am I going to do to both sides of the equation in order to complete this. What am I going to do to complete this square? And in order to complete this square, I have to add 1 squared on this inside this parenthesis. But that doesn't really mean that I'm adding 1 to the equation. What I'm actually adding is a 3. So I have to add 3 on this side. Once I do that, I have y minus 97 equals 3 times x plus 1, the quantity squared, which helps me make this into vertex form. Plus 97. So because my h is -1 and my k is 97, this is going to be my vertex. So in order to graph this is a big pain. This is a little hard. But we have to kind of start with a smart graph. So we have to think about the behavior of this graph. So what I'm going to quickly do is I'm just going to make a sketch. This graph, where does it exist? -1, 97, way up here in the second quadrant. And it's a positive a. So that means it's going to look something like this. So I want to do a smart graph, and I really only want these parts of the coordinate plane. I only want the first 2 quadrants of the coordinate plane. Now the problem with this vertex is that I have a 1, a -1 for my x, but I have a 97 for my y, which means I can leave this, the x, whoops, there you go, I can leave the x as a 1 scale, 1, 2, 3, 4, 5, -5 here, and 1, 2, 3, 4, 5, +5 here. So I can leave the x as a 1 scale, but I certainly can't make the y a 1 scale. Now I had some questions about, well, can I break the graph? And in essence you could, but it's not really accurate. It's not really what we need to do. Breaking a graph is really only for when you're doing an application question and where the axes actually mean something, okay? Kind of like what we're doing with the gold and the llama question, but we're not going to go there yet. So instead of breaking this graph, I'm going to say, how can I get 97 on this? I reckon I can go up by tens. So 1, 2, 3, 4, 5. This is going to be 50. 1, 2, 3, 4, 5. This is going to be 100. Okay, 1, 2, 3, 4, 5. This is going to be 150. So I could do it that way, and now I'm just going to really estimate. Well, I have exactly where -1 is, but really where is 97? 97 is somewhere here. It's pretty close to 100. And the first idea that we would have is, well, we could rapid graph because this is an integer. So I'm going to move up 3 over 1, and I'm going to move up 9 over 1 if I rapid graph. But the problem with that is that when you're moving up 3, you can't go up 3 ticks and over 1. You have to only go up 3. So if I go up 3 from 97, I'm going up to 100 and over to 1. And so I can still use my rapid graphing technique to do this, but I could also use my table of values. And it's really important that when you do use your rapid graphing technique that you keep in mind that your x scale and your y scale are completely different. So from here, if we go up by 9, we're only really going to here, and then again, because it's not super accurate, we just really want to sketch and we really want to understand where this is. Now the cool thing about this with the rapid graph and the way I drew this is I can keep going. So if I'm going to remember the original is up 1 over 1, up 3 over 1, up 5 over 1. So I could go up 15 and over 1, but then again that's really hard too. So from 109 up 15 is what? When you add 109 to 115. 15 to 109. That's going to be 24, right? Yeah, I think that's right. 115, yes. Okay, so I have to go up 10, 20, 4 is somewhere about here, and then so it's a little underneath the half. And so I can keep going here if I want to. Now remember, you don't have to keep going. You can just estimate. All right, and then you need 5 points. So then I take my trusty pencil out and I make a nice curve. And I make it keep going out, right? And there's the answer to number 5. That's how you would graph that. Okay? So that's number 5. The next thing I want to go over with you after 5 minutes is the gold question, the gold prospecting question. So we talked about having the perimeter was 1,000 feet, 1,000 yards. Okay? So if the perimeter was 1,000 yards, that means the base plus the height is going to equal 500 yards, because twice the base plus twice the height equals 1,000 yards, and that's perimeter. So once we know that, we can solve for one of these variables, and I decided to solve for h. So h equals 500 minus b. Once we know that the area of any rectangle is base times height. So, well, what is the base? The base is the base. So I didn't change anything for the base. So my area is going to be base times height, base times height. And what did we just say the height was? The height was actually 500 minus b. So when I actually multiply this out, I get 500b minus b squared. Now we also did this with the opposite way, and we got a equals 500h minus h squared, which is ultimately going to be the same idea that I want to go over with you. It's really the same idea. The one thing I really want you to make sure of is you have to remember that the a value is the coefficient in front of the quadratic term. So we really have to look at this very distinctively. The 500 is the coefficient on the linear term. It's not on the quadratic term. So you can't look at 500 as being your a. Your a in this case is actually -1. And we know that when a is negative, it's a sad parabola. So that means we're going to have a maximum point. Okay, well, what does that maximum point represent? Well, we have to look at what the question is asking. So the question is asking, well, we want to find the maximum area. So how is the maximum point going to help us find the maximum area? So either way we look at this one, let's look at this one because this is the one we did in class. My x value is my height because that's where the x really belongs in the quadratic equation, the quadratic function. So I'm just going to sketch this graph, and notice that I'm only sketching the first quadrant of this graph, because if I sketch the first quadrant of it, I know that I have to only have positives because it's distance, and distance can only be positive. Okay? So now this is the tricky part. What is the y value? In this case, the y value happens to be the area, not the base. Okay? So we're looking at this problem in terms of height and area. Now we know that it's a sad parabola. So it's going to go up and it's going to come back down somewhere. We don't really know where these numbers are, but we can figure them out. Can you, and now this is where I'm going to end this tutorial, can you figure out the maximum point of this function? Now you got to remember that this function is a equals 500 h minus h squared. And I can rewrite this function using x and y. Y equals 500 x minus x squared. So this is your function that you can graph on a coordinate plane. But this is the function of what it actually means to be this prospector for the gold. Once you have that, you can figure out the maximum. I want you to think about that. Once you've thought about that, find the maximum point. Maximum. Sorry about that. Find the maximum point and identify what it means. The next video will give you the answer to the llama problem.